Hey, what's up, muchachos? Today we're going to be talking about related rates problems, but not just any related rates problems. These types of problems have more of an improvisational flair than the problems that we're used to working with in most math classes. Keep in mind that the steps that we normally associate with related rates problems are still going to apply here very directly. The only difference is that in order to use the information that we're given, we're going to have to manipulate our equations in one way or another. Obviously, because of the huge variety of problems that we could have, it's going to be difficult to narrow in on a singular strategy that we can employ in these types of problems. However, I think if we take a look at the example that we have on the screen, it's going to make things a little bit clearer for us. The problem reads, sand falls from a conveyor belt at the rate of 10 cubic meters per minute onto the top of a conical pile. The height of the pile is always 3/8 of the base diameter. How fast is the height changing when the pile is 4 meters high? Give your answer in centimeters per minute, and note that the volume formula for a cone is V is equal to 1/3 pi r squared h. For any related rates problem, the thing that we're going to do in the beginning is to classify the information that we're given under something that we call a Wiktionary. When we do this, we are going to consider each piece of information that the problem gives us, and we're going to be able to determine if we're going to have to manipulate our equations at all. Let's create our Wiktionary. We'll start by writing the letters W-I-K. Remember, W-I-K stands for what I know. Now we're going to classify the information from the problem. Always look for formulas first. These are going to be the most useful things. These are the things that we're actually going to have to do work on. For us, that's V is equal to 1/3 pi r squared times h. Once we have that, we're probably going to want to look for actual numbers in the problem. I see that I have a rate of 10 cubic meters per minute right here. The word cubic clues me in that this is the rate of change in volume, so that means that I have dV over dt, and it's equal to the number that we had, 10. The next thing the problem tells us is that the height of the pile is always 3/8 of the base diameter. It may not be clear to us how we're going to use this just yet, but trust me when I say related rates problems don't mince their words. Write this down. It's also important to note that the problem is interested in what's going on when the height is 4 meters high. So we're going to write down that h is equal to 4, and we're probably going to plug that number in later. So that's all the stuff that we know. What we're interested in finding is how fast the height is changing. In other words, this problem is asking us to identify what dh over dt is. What is the rate of change in the height? From here, what we would usually do is differentiate both sides of our equation with respect to t, and then we would plug in the values from the Wiktionary to solve for the unknown. Now, the problem here is that if we take the derivative of both sides, on the right, we're going to have an r left over, and because we took the derivative of r, we're also going to have a dr over dt. Looking in our Wiktionary, we can see we don't have a value for r, and we don't have a value for dr over dt. Under certain conditions, we can find those things, but in the case of this problem, where we're looking for the rate of change in the height, that's going to be impossible. Basically, we're going to have 2 or 3 unknowns, and that's too many for us to be able to solve the problem. So, how do we proceed? Well, we need to somehow get the r in the volume equation into something that has to do with h's. And we're going to get there by using the h is equal to 3/8 d that was given to us in the initial situation. Follow along. So first things first, I know that the diameter is equal to twice the radius, so I can rewrite my formula in terms of r as 3/8 times 2r. A little simplification will get us the much nicer h is equal to 3/4 times r. I don't want h equals, though, because that would allow me to replace h in my equation, and I want to replace r, so I'm going to multiply both sides by the reciprocal of 3/4 to get 4/3 h. I take this expression now, and in my volume formula, I'm going to replace r with the 4/3 h. In doing this, folks, we're going to not only remove the r from this equation, but we're going to get rid of the eventual dr over dt that was going to give us problems later on. When I plug in, this is going to give me v is equal to 1/3 pi times 4/3 h squared times h. When I square my parentheses, that's going to give me 16/9 times h squared. I'm going to combine all of my terms through multiplication here, and that's going to give me an updated volume formula of 16/27 pi times h to the third. Note how we only have v and h in this case, no more r's. This means that we're going to be able to differentiate now, and we'll also be able to plug in all of the values from the Wiktionary. There's going to be no unknowns except for the one that we're trying to solve. So we do d over dt to both sides of this updated volume formula like you see here. The derivative of v is 1, and then since we took the derivative of v, we need to put the differential dv over dt. This may look a little bit complicated, but it's the normal power rule. 16/27 times 3 is 16/9, and then I do pi h to the second, and since I took the derivative of h, I'm going to put dh over dt. You'll note here that I'm circling the dv over dt and the h. That's because I have things to plug in for those, and so I will do just that. dv over dt was 10, h was equal to, in this case, 4, and then I have my dh over dt, which is the unknown for which I'm trying to solve. 1 times 10 is 10, and then 16/9 times pi times 4 squared altogether is going to give me 256 pi over 9. I'm going to write this as a singular fraction because it's going to make solving for dh over dt easier. All I have to do is multiply both sides by the reciprocal. So let's do this. I'm going to multiply the right by 9 over 256 pi, making sure that my fraction bar extends over the pi, and then same thing on the left-hand side of the equals. It's important to note that if you're trying to learn this skill for the AP exam, that when you round your answers, you always want to try to round to the nearest thousandth. That would be the third decimal point. In this case, 10 times 9 over 256 pi is approximately 0.112. We always want to write our answer out as a complete sentence to show that we understand what it is that we found. What we found here is the rate at which the height changes. So we say the height changes at a rate of about, because we know that this is not an exact answer, 0.112, and then our units were meters per minute. Wrap that up and put a bow on it, folks, because that is a model answer for these types of problems. So, as a review here, remember that the steps for related rates problems remain the same. We still set up our Wiktionary, we still differentiated both sides with respect to time, and we still solved for the missing value. The difference here was that if we tried to differentiate the equation that we were given as it is, we would have had too many unknowns floating around. If you don't notice that from the get-go, here's the good news. When you get into the actual process of differentiating, you will find out very quickly that you don't have enough information in the Wiktionary to plug in. If that's the case, then take a look at what the problem is asking you to find, because that's going to allow you to direct your focus on the things that are going to matter in the long run. In our case, we wanted to work in terms of h, so that meant that in the volume formula that we were given, we somehow needed to be rid of the r. So we took our h is equal to 3/8 d equation, and we got it in terms of r. More accurately, we were looking to get an r equals equation so that we had something to replace r with in the volume formula. Remember, whatever variable you're trying to replace, that's the one you want to solve for in those little h is equal to 3/8 d type equations. After you do all that substitution and replacing, folks, you can proceed as you normally would with a related rates problem. And with that, I think I've given you guys all the information that you would probably need to be successful on most of these problems. Of course, practice and experience is going to enable you to approach these things from a much more enlightened perspective, but you have to put the time in first. So thanks for coming, folks. Get that practice done, and we'll see you next time.